Hey everyone, welcome back. So in the previous video, we have learned about the resource request and limit, and today we are going to learn about the replica set. So in this video, we will cover what is replica set, why do we need it, how does the replica set works, and we will also do the hands-on to see everything in action. So let's get started. Now imagine your application running in a single pod and everything works fine until the pod crashes. When it crashes, your application goes down and you just start seeing the error. And you need to manually create a new pod to bring the application back online. So if your application suddenly receives a lot of traffic, a single pod may not able to handle the load. So in short, a single pod is the single point of failure. So this is where ReplicaSet help us. So what is ReplicaSet? A replica set is the Kubernetes resources that ensure a specified number of identical pods are always running. So in simple terms, if you tell ReplicaSet, I want 3 copies of my pod should be always running, and the replica set continuously monitor the cluster and make sure this requirement is fulfilled. So if your pod crashes, replica set automatically create a new one. If you delete the pod, replica set create a replacement of the pod. And if the node goes down and the pod lost, replica set create a new pod and Kubernetes schedule it on the different available node. Now let's see how replica set works. So let's understand the YAML file that we're going to create. So if we remove this section, it would no longer a valid replica set. And these fields are what make replica set different from the pod. So here we have a 3 component. First is the replica set. This tells the replica set, I always want 3 pods should be running. Then we have a selector. Now the selector is used to identify and manage the pod. Replica set look for the pod that have label app is equal to my app. Any pod with this label is considered as a part of replica set. Then we have a template section. The templates is the blueprint for creating new pods. So whenever replica set need to create a new pod, it uses this template to create a new identical pod. Suppose the desired number of replica set is equal to 3, but currently we have 2 matching pods that are running. Now replica set controller use the selector to find the pod with label app is equal to my app, and they count how many matching pods that currently exist. Then they compare the count with desired count. Since only 2 pods are running, it uses the pod templates to create a new additional pod. As a result, cluster return the desired state of 3 running pods. Now let's see replica set in action on the real Kubernetes cluster. So open the Killercoda.com, select the Kubernetes playground, and wait for the environment to load the cluster. Once it is loaded, let's verify the cluster. And you see the control plane and worker node are in ready state. So let's get started. So first we will create a replica set file. Press -I to paste the YAML file. And in this YAML file, we have defined replica set is equal to 3. Then we have a selector and template section. Templates is the blueprints for creating a new pod, and selector is to manage and find the pods. So press :WQ to save and exit. Now let's create the replica set. So we have created the replica set. Now let's verify it. Now let's understand each column one by one. So first we have a desire is equal to 3. That means we want 3 pods should be running. Then we have a current is equal to 3. It means how many pods are running. And then we have a ready is equal to 3. That means all 3 pods are ready and healthy. Now let's check the pod status. And you see all the 3 pods are running and all 3 pods are created by replica set. And notice the pod name, they have a start with my replica set followed by random suffix. And this is how you identify the pod created by replica set. Now let's describe the replica set. And look at these important sections. So we have a selector which will show the labels used to find the pod. Then we have replicas which will show the desired state, current state and ready count. Then we have a pod templates, so the templates that used to create a new pod. And we have also event sections where you see the all 3 pod has been created. Now let's try to list the pod again. Now let's see if we delete the pod, replica set create the pod or not. And to do this, we will delete the one pod and we will check the status at the same time. So we need to replace the actual pod name. So we will copy the pod name from here and we will paste it here. Now the first line you see our pod has been deleted, and as soon as the pod has deleted, replica set create a new pod and you see container creating. So currently we have a 3 pod running. Let's try to scale to pod up to 5. Let's check the status now. And you see the 5 pod running. That means the pod has been scaled from 3 to 5 by replica set. Now let's scale down the pod and check the status again. And you will see only 2 pods now, and 3 pods were terminated automatically. Check the replica set again, and you see desired state is equal to 2, which matches the scale down command. Now let's see relationship between the replica set and the pod. So we will run kubectl will get pod -o wide, and it will give you detailed information of the pod created by ReplicaSet. Now let's try to describe one pod. So we need to copy the pod name from here, and we have described the pod. Now scroll to the top and look for the control by, and you see here we have a control by. It means this pod is controlled by ReplicaSet, and ReplicaSet name is equal to my ReplicaSet. And this confirm this pod is owned and controlled by the ReplicaSet, and if you delete the pod, ReplicaSet will create a new pod. Now let's try to delete the ReplicaSet, and to delete it we will run kubectl delete -f, that is file name, and then file name, and our ReplicaSet has been deleted. And you see we don't have. So let's quickly recap what we have learned today. So ReplicaSet ensures a specified number of identical pods are always running. A ReplicaSet continuously compare the desired state and actual state of the cluster and take action to make them match. If a pod crashes or deleted, ReplicaSet automatically create a new pod. ReplicaSet track the pod by labels, not by the name. And here is the few commands that help us to create the ReplicaSet, and we have a many more commands that help us to troubleshoot the ReplicaSet. So that's everything about the ReplicaSet. In the next video, we'll learn about the deployment. If you have any question, feel free to ask in the comment below. And thanks for watching, and I will see you next video.